So when we talk about substitution, we need to solve an equation, or a system of equations. So we have two equations. And our end goal is to find the XY coordinate where they cross. That's the whole purpose in us solving these, okay? So when we use substitution, this is one method. We can have X or Y equals. So I have Y equals 3X here. So I want you to think about, if Y is 3X, then in my second equation where I have Y, I can replace Y with 3X. So I'm taking two equations and I'm going to squish them down to make them one. So when we do this and we make one, now it's like unit 1. Now it's like 8th grade. We're just going to solve the equation that's only going to have one variable. So let's see what this looks like. If I am going to take this 3x and I'm going to put it in place of the y. Pay attention to the fact that it's 2 times y. That's why I put parentheses here. So I have my second equation is 5x plus 2 parentheses. Now, I'm not going to write y. My y, I'm going to substitute with the 3x because I'm saying in that first equation that y and 3x are the same thing. And then I'm going to write equals 44. So I've taken the 2 and I've made 1. So now it's just like unit 1, right? We have to follow the steps. We're going to distribute. 2 times 3x is 6x. Don't forget to write all the rest. And now, second step, collect like terms. We can put x's together. 5x's and 6x's is 11x's. I don't need to move my letters to one side. I don't need to undo my add subtract. I do need to undo my multiply divide. 44 divided by 11, x equals 4. So now that we know one of our coordinates, I'm going to come down here just a minute. Write your solution as an ordered pair. So I know my x. My x is 4. Now we got to find our y. We're going to substitute into one of our original equations.
Wait, isn't it 3?
So I'm going to come up here. You can choose either. I'm going to tell you I'm going to choose this first one because it's shorter. It looks a little bit easier to manipulate. So if y equals 3x, and now I know that x is 4, so I'm going to substitute again. If x is 4, I can say y equals 3 times 4. It's kind of like in unit 1 when we got our answer and we plugged it back in to check it. Same thing. So 3 times 4 is 12. There's my second part of my coordinate. So if I was to change those to y equals and I was to graph them, they would cross the 2 lines or they would intersect at the coordinate 4, 12. Now, we're not going to change and graph, but we can double check it. Okay, so this is where your yellow calculator is going to come in handy. So to check this, we need to plug, just like when we did inequalities, we're going to plug our x and our y into our original equation. So my original equation was y equals 3x. And I know that x is 4 and y is 12. So in my calculator, I can say 12 equals 3 times 4. And when I put that in there, that in fact is true. Now it has to be true for both. My second equation is 5x plus 2y equals 44. So now I got to plug my x and y into that. So 5, my x is 4, plus 2 times my y is 12. When I type this into my calculator, I should in fact get true. If I get true, then yes, I've solved it correctly. If I get false, then there's a mistake and I have to go back. So this is in fact true when I check it in the calculator. On this next one, I want you to notice it's not y equals. It is x equals, don't freak out about that. That is okay. This says 1/2 times x, I'm going to put a parentheses there, plus y equals 1. And I know that x is 2y plus 14. So I need to put this whole 2y plus 14 where the x is, because we're saying that equals x. So I can replace x with 2y plus 14. So I have 1/2 parentheses, and instead of x, I'm writing my substitution, my 2y plus 14. Don't forget to write the rest of that first equation that we're plugging into. So we still have plus y equals 1. Now that we've plugged it in, we're just going to solve like we've done in the past. We're going to distribute. Half of 2 is 1. Don't forget your y. Half of 14 is 7. Bring down the rest. You can even put the 1 in front of the y if you want. We can collect like terms. Y and y is 2y plus 7. We don't need to move our letters to one side. They're already on one side. Undo the add subtract. So we need to minus 7 because it's a positive. Be careful with your signs. 2y equals -6. And then last step, always divide by the 2. -6 divided by -2 is a -3. And remember, that's only half of your answer. Our answer is going to be an xy coordinate. So my y is -3. So now we need to plug in to an original. And guys, whichever one is x or y equals, that's usually the one that I plug into. It's just a little bit easier. It's a little less messy. So if we put in, we're going to put our 4, I'm sorry, was it, no, sorry, -3 in place of y. So I'm going to come down here. I'm just going to rewrite that original equation so I don't mess it up. And now they're telling us that we got on that first part, y is -3. So I'm going to end up putting it here. So x equals 2 times -3 plus 14. I could put that in my calculator, or I can solve it individually. 2 times -3 is a -6 plus 14. So now a -6 and a 14 is a +8. So that's going to be my x. So if we graphed these and we looked for the point of intersection, it will be 8, -3. These are a special case. We're going to run through these super fast. So this is our y. We're going to put it here. 8x minus 2 parentheses, and in place of y, we're putting 4x plus 7. Don't forget to write the rest of it. We are going to distribute. Be careful with your signs. A negative times a positive is a negative. A negative times a positive is a negative. Now I want you to see what happens here. We have 8x minus 8x. Those cancel. So we're left with -14 equals -2. Does this make sense? Is -14 ever equal -2? No. So that means that these lines are going to be parallel. And if our lines are parallel and our solution is where they cross, they're never going to cross. So this means that there is 0 solutions or no solutions.
Wait, so if you were to divide it though?
Last example. We're going to put this in place of x. 2 times -3y plus 7. Don't forget to write the rest of it. Sometimes I do that, so make sure you write the whole thing. And again, after we've squished them from 2 to 1, now we're just going to solve it like we used to. Negative positive is a negative. Positive times positive is positive. So again, -6y and positive 6y, those eliminate. There's 0 y's, it's poof gone. But now we have 14 equals 14. Well, this is always true. So that means that if we get something that's always true, we're going to have infinite solutions. So we could put any xy coordinate value we wanted into both equations, and it will be true every time. So to wrap up, we have a little table down here we're going to fill in. If we have two intersecting lines, they look like this. Our solution is, we have one solution. It's going to be where they cross. If I have two parallel lines, if you look, we get a statement that doesn't make any sense. 1 is never equal to 4. They're parallel. This is none or no solutions, 0 solutions, whatever you wanted to write. Coinciding is when they are true, right? 4 equals 4 always. So that means we have this line, and then we have a second line that is exactly identical. So we only really have one line there. So all of the coordinates match. So this is when it's going to be infinite.